Hello, welcome to my presentation. I'll be giving you some how-to and tips on helpful tactics for creating the FSAE car chassis in SolidWorks. Um, First, I'll go over simple tube making. The easiest way I find to make a tube is to just simply sketch a line in the sketch feature, um, and then sketch a circle and do an extruded circle, which will create a solid tube. And then once you have your solid tube, make an extruded cut um, by using the center line and the end of the tube as the face, and then setting the diameter of the inner circle by marking the distance from the outside edge to the inner edge of the circle in order to make the wall thickness correct. And then you just extruded cut through all, which will result in a tube. Once you have your tube, you're going to want to either notch it or mate it to something. For simple tube notching, if you want to just notch a tube very quickly, you can you sketch a plane through the tube, and then at whatever angle you orient the plane, at whatever angle you want your notch to be at through the tube. And then once you do that, sketch your circle, same diameter as the tube itself, and then or either the same diameter as the tube itself, or make it the same diameter as what tube you're going to notch the tube you're modifying to. And then again, extruded cut. You might need to cut through all in two directions, and then that'll give you your notch. In the way of mates, when you go to mate your tube to another tube, as I have here in my example, I have two tubes. They're both the same diameter because it's just easiest that way. One is the tube I notched in the previous slide, and then the other is just a quick sketch that I sketched up. In order to mate it, you have to select the two surfaces that will be mated. So first, you can see that I've selected the notched surface of the tube as one of my surfaces that will be mated, and then in the next slide, I have selected the outside of the tube that it will be mated to as the other surface that will be mated. And once you select the two, it'll put them together in some like haphazard way depending on how they're oriented. In this example, these tubes are not fully defined when they're mated. If you were to play with this design, you could slide the tube up and down and spin it around on the other tube. In order to do that, you have to create some parameters or reference points to dimension the one tube to the other. This will make it fully defined, and then you won't be able to like slide them on each other or anything. This is also very important for when you move on to doing FEA analysis on these tubes, because if it's not fully defined, it will display a bunch of errors, and it won't actually give you it won't allow you to run the simulation. Alright, next I'm going to talk about unrolling tubes. This is how to create a sketch for when you're notching them. This is how to create the actual reference line that we put around the actual physical tubes in order to notch them properly. So first, you have to take the tube that you want and insert it as a separate part into a new design so that it's just by itself. Once you've done that, you have to create a plane perpendicular to this actual tube in order to draw and make the cuts in order to unroll this. The next step is to extruded cut a very small section down one of the sides of the tubes. Basically, just draw 2 lines from the center line to the outside, to the outer edge of the tube. Um, Once you've done that, dimension them to each other so that it's a very, very small angle, like 0.05 degrees if you like. Um, then you, once you've done that, you head into the sheet metal feature and then select bend feature. This will bend it flat, and then it will completely unroll the tube, and you'll have the outline of that notch that you need to make. After you've done that, it's pretty simple. Just create a drawing of it, and then print it out, and you're all set. Once you've done that, just cut it out, wrap it around the tube. Make sure that you orient it correctly. That's very, very important. If it's not oriented correctly, you're going to have tubes pointing in haphazard directions. So pay special attention to that. Right. And then this slide has the picture of the unrolled tube and the drawing of it. So the next section I'm going to go over is tube trimming. This is another method for notching tubes. For tube trimming, it's very important that you have your manufacturing plan hashed out beforehand, because this will make sure that you know like which tubes are going to be trimmed in what direction on complicated joints such as the bases of all of the roll hoops, or the joints where the A-arms connect, where you're having multiple tubes coming in being notched to each other. Once you have your plan, you can select which bodies you need to trim, and then so you select the body to be trimmed, which is the tube that you want to notch, and then you select the trimming boundary. The trimming boundary is the surface that it's going to use to actually trim the new tube, the body to be trimmed to. Once you've done that and it's dimensioned properly and everything, it'll allow you to trim the tube. And then you go back to the unrolling tube step, and that's how you get your drawing again. For FEA analysis, this is the section where you actually test the parts that you're going to be putting on the car. This allows you to test like what type of forces and pressures they can stand up to. And then it allows you to get a factor of safety, so you can trim or add to different tubes to make sure that you have that factor of safety that you defined already. So first things first, your part has to be fully defined. If it's not fully defined, it will not allow you to run the simulation properly. So you head to your study advisor section, and then once you have your part selected, you head to study advisor, create a new study. Once you're in there, you'll be able to add fixtures to it. The fixtures are what keep the part in place. So you have to add basically mounts to it. And then once it's fully mounted, you add your forces, and then you add and then you define the strength of your forces. You can add twisting motions, you can add pushing, pulling, all types of different forces to it. Once you're satisfied with the way it is, you can hit run simulation, and once you run the simulation, it will display the areas of high stress on the part as well as the factor of safety. And then, like I said before, you can tweak the part, test it again, add wall thickness, subtract wall thickness, all different things. And this is the section showing what it looks like when the forces are on it. The green arrows, they're very small and they're hard to see, but those are the mounts, or the fixtures, and then the actual force is the purple arrows. And then we found a few helpful tutorials as well that are very, very useful for you guys to use. Sheet metal, that's some extra tutorials on how to unroll the tubes. Weldments, that's another type of mate, which is more realistic to like how the weld beads are going to be on it. 3D sketching is very useful. 3D sketching with planes is also very useful. They allow for more usability through SolidWorks in order to create more complicated parts. Simulation Express, that is the simulation for FEA. That's going to help you a lot too. A lot of working through FEA analysis is trial and error for some of it, and a lot of the things that you're going to be doing with SolidWorks, you're going to have to learn as you do it. It's very hard to just explain it to people, but once you get going with it, you'll find that you'll learn it pretty quickly. And finally, SolidWorks Flow Express. That's a very helpful tutorial on how to. It's kind of like FEA analysis, except for liquids and gases that flow through parts. So that'll be helpful for creating the intake and stuff like that.